Hi everyone, I am M.Yogadharani, working as Assistant Professor in Department of Computer Science and Engineering at SNS College of Technology. Today, I will explore one of the most fascinating concept in data structure, that is a minimum spanning tree, and it is a beautiful blend of mathematics and the real world problem solving used in everything from network design to image processing. And This is the roadmap for today's session. I will begin with a quick recap of graphs and then understand the connectivities, what is minimum spanning tree and what is spanning tree, and with based on the design thinking concept. So as I already teach you that graph must contain a vertices and edges. So edges is the one which connect the two vertex, and the weights or the cast between the two vertex, and the types of graphs such as directed graph, undirected graph, weighted graph, and then what is cyclic graph, what is biconnectivity. So biconnectivity is nothing but in a graph there is a vertex. That vertex, if I not visit that vertex, then it is not fulfill uh, to visit all the vertex, and that one vertex, if I not visit that, that graph must not be complete, and that point is called articulation or a connectivity point. An objective of today's is to understand and apply the minimum spanning tree concept in algorithms in both the Kruskal's and Prim's algorithm. And these two algorithms are purely optimization approach, and it is also used for real world networks and clustering problem efficiency. So in empathy part, let emphasis with the real world persona like Ravi, telecom network engineer. He's tasked with the connecting multiple cities with the fiber cables, and his goal is complete connectivity with the minimum total cost. And if he connects city randomly, cost will skyrocket. So if he keeps skip connection, the network breaks. So how can Ravi design the most efficient network? And that's what MS, that is a minimum spanning tree, comes in. So in define part, here is our problem definition. Here we want to connect all the nodes or cities in such a way that the total cost is the smallest possible, and there are no loops. That is, no cycle should be found in a graph or a redundant path. This gives us three pillars of minimum spanning tree. That is connectivity. The whole graph must be visited with a total minimal total weight, and then it should not forms the cycle. See, this is the graph that is three vertices, namely A, B, C. So the three pillars are should be connected with the all vertices, and the small trick behind this is how many vertices are there. Should be if there is a n vertex, n vertices, so edges must be of n minus 1. See here, A, B, C are three vertices and edges are 3. So in our spanning tree, 2 vertex. So if there is a n vertex, so n minus 1 edges are there. Then small activity here. Now let's make it a small, make it practical. I will divide into groups. Each group will receive a graph representing a network of cities, and here we find the MST using either Kruskal or Prim's algorithm. And then, so here comes ideate part. In ideate part, mm, uh, Ravi could use brute force for all possible networks. So brute force is nothing but try all the combinations. So it must be slow, but that is a cheapest slow connection that does not create circle. So in our minimum spanning tree, the properties are should be connected to all the vertices, and then it must be in a total minimal cost, and then for last one is should not form a cycle. So in I here solve here a greedy approach. So greedy algorithm is nothing but always pick the cheapest safe edges. So by 36, I split into the four divisions like 20 plus 10 plus 5 plus 1. So this is wise level pick the safest edge, and always Kruskal's algorithm build from the edge based graph, and Prim's algorithm build from the vertex based one. Next, move on to the prototype. Here, I'm using first algorithm is a Kruskal's algorithm. Here, I sort all the edges by weighting and keep picking the smallest one that does not form a cycle, which we check using the disjoint set union find structure and stop from the v minus 1. As I told you already that if there is a 5 vertices, so the edge must be of n minus 1. So there is a 5 vertex, so only 4 edges are possible. That graph is only the correct minimum spanning tree. So see the final structure of the above graph. A to B, the cost 1, and B to E cost 3, E to C cost 5, and E to D cost 2. So here, see there, the three pillars like with the edges connecting all the vertices with the first one, and the second one is the total minimum cost is 1 plus 3 4, 4 plus 3 8, 4 plus 5 9. So the total cost for visiting all the 5 nodes is 11. And then last one is should not form a cycle. So this is the minimum spanning tree. And second approach is Kruskal's approach. Sorry, second one is a Prim's approach. So in this approach, we must maintain a adjacent tree matrix, and this is built from the vertex centric. So it begins at any vertex and it keeps explaining by adding the cheapest edge connecting the current tree to a new vertex. And it is like spreading a network from one city outward, and similar to how power grid expands, and using the priority queue and minimum heaps make it faster. And the complexity for a Prims is big O of V square. So check this graph. Here I have 2, 4, 6, 7 vertices are there, and here the adjacent matrix would be what are the vertices and what are the known vertices and distance between the source and the path. I traveled from the vertex V1. So V1 to what are the edges out degrees are V3, V4 and V2. Among these three, which has the lowest one is 1. So draw line from V1 to V4. Then in V4, travel how many edges are there? V4 is a strongly connectivity one. So it has the edges for all the vertices. So it goes from V4 to V3. Then V7. Likewise, I have built the Prim's algorithm. Then what are the technical depths are it used for network design, that is building efficient computer, electrical and telecom networks, and then transporting planning like designing low cost road, rail or pipeline routes, and then it's mainly used for image processing like segmenting clustering or segmenting, especially in Kruskal based ML model. And then civil engine is also used for irrigation or utility layout to minimize material use. And future scope or interdisciplinary is based for um, dynamic MSD algorithm for real-time networks, and it's also used for parallel MSD in distributed. It is also mainly used for IoT smart infrastructure. So the summary of this essence, sir, today I discuss with you what is spanning tree, what are the three main pillars in minimum spanning tree, and how what are the famous algorithms in minimum spanning tree, sir, Kruskal's and Prim's algorithm, and its applications and its advantages, and this is the small mind map for minimum spanning tree. So thank you. I catch you with the another video. Thank you all.